Hello, welcome dear colleagues and attendees to the third International Conference on Signal Processing and Machine Learning, uh, SPML 2023. It is an honor to be gathered here with academics, researchers, and students from all corners of the world to share our latest findings and ideas in the exciting field and emerging field. This annual conference has become a renowned platform for the exchange of knowledge, inspiration, and collaboration among experts in the area of signal processing and machine learning. It is a forum for discussing emerging trends, innovation, research, and practical application that impact on our daily life. That is, I must say thanks to organizers for organizing such kind of conference. So, dear attendees, I am Mazhar Javed Awan, Assistant Professor, Department of Software Engineering at University of Management Technology, Lahore, with over 20 years of diverse experience in the academics, government and corporate sectors, teaching as well as industrial experience. So with a PhD degree from University of Technology, Malaysia, so on medical images direction system, I have done a PhD. I have become a highly sought after trainer, consultant, and curriculum member in the field of artificial intelligence. As a prolific researcher, so I have published more than 55 research papers in top conferences and journals in the field of natural language processing, big data, data sciences, machine learning, deep learning. So these are my fields. So I have published more than 55 papers, and my citations are more than 1400 and a Google Scholar. So my work has received significant recognition, including the Research Excellence Award for the highly cited papers from UMT, and being named one of the top 2% globally influenced scientists by Stanford University in 2022. So I was also the top 2% scientist, which Stanford University generated the list. So overall, my expertise, knowledge, and expertise make me a valuable contribution to the field of artificial intelligence. I am excited to share my insights with fellow researchers and academics in this conference of SPML 2023. So now I would like to talk about my topic. So I'm sharing my screen. Okay. So you can see, okay, you can see my screen. Okay, the today topic about my talk is structured and unstructured knee anterior ligament tears data classification with machine learning and deep learning. So we are in University of Management Technology. My co-authors, my co-worker, my supervisors from University of Technology Malaysia. So my LinkedIn profile is also here. You can explore me. So at here you can see first I would talk about the some problem introduction. So what is the problem introduction? We have a problem of ruptured tears, ACLs actually. So we can say in each year around 1 lakh to 2 lakh people are suffering for ACL tears, rupturing ACL tears. So annually they have spent around $500 million in the USA. Okay, so this the tears, ruptured tears are common in among the football players, soccer, athletes. So if damage is much higher, then it will causes a cartilage loss and ruptured in the anterior cruciate ligament, which causes the knee osteoarthritis. So we can see this in the figure. In ACL injury, at its the tear is present at this figure, and in MIR we can say in cartilage loss another osteophytes is to be present here. So what is the research aim of my study? So the main aim of the research to improve the classification of imbalanced knee 3 ACL tears data for accurately The result of the study can be used to identify the early stage of ACL injury to avoid knee osteoarthritis. Okay, so this is my research aim. So what are the problems in a researcher background? So we have, after study a lot of literature, we found mainly two kind of problem. Handle class imbalancing to detect it in an efficient way. There is no efficient way for in the case of class imbalancing problem. And other one problem is regarding improvement of classification. So there is a problem to achieve highest accuracy in especially in the unstructured data. So MIR images. So these are the problems. So for this further, there are two gaps, research gap. One, unbalanced data sets, efficiency affected in multi-classes. Is that there is a problem, and time the if classes are not balanced, if classes are imbalanced form, so then the result would found the biasness in the result. So the second problem, in the terms of accurate result or performance increase enhancement is another challenge for in case of computer science and deep learning. So we have this kind of challenge remain a problem. Okay, so efficient early near detection and improved performance. So these are my research problems. So what are the research contribution? Now I have divided work in the two forms. So one problem is my research contribution one is regarding an improved 3 ACLTL classification method. So which is totally related to structured data, because I'm taking the structured data at here. There is a CSV file here. So at CSV file, we have applied different machine learning models. So we applied almost 12 machine learning models. So, but we applied some kind of boosting and backing models. So there are 4 models we have shortlisted because these accuracy, because we after feature learning and other things, we found that these models produces good accuracy results. So one of them is random forest, catbos, light gradient boosting machine, and extra tree classifier, which achieved impressive accuracy around 95%, more than 95%. Okay, so we also applied some oversampling. So these are the oversampling techniques we used in to handle the class imbalancing. So major contribution of this working for the structured data. So comparative analysis, we did a comparative analysis and we applied extensive visualizations, plottings, and other things to making best features out. Okay, so then achieved better accuracy in terms of F1 recall, precision, and accuracy. So these are the results. So for this, we have published a paper regarding the machine learning based performance comparison to diagnose anterior cruciate ligament. So this is our paper, so which is in a Q2 rank journal. So you can find this in this link. So so what we have done in this paper, mainly we have bagging methods, random forest and extra tree classifier. For boosting method, we have cat boost and light gradient boosting. So this is the problem mainly. And resembling, we have a unbalanced form of data. We have the 3 classes. We have a multi-class problem. So in healthy tears, we have more than 75% ratio, and in terms of partial, we have 18%, and full ruptured, which is a mostly causes the osteoarthritis. So which have very limited data, 6%. So so for this we have applied different ways for class imbalancing. We also tried undersampling, we tried class weighting. So but for the oversampling, we have a very good results. So for this in this case, you can see the ratio of all the 3 classes will become equal. So it is our framework, and we have initially imbalanced data sets. So for data preparation, we have a balancing techniques with the help of oversampling. So after data exploration, heat maps, and plotting, we have separated our data into 75% training and 25% for the testing. So for this, we have applied these four models after adjustment of some hyperparameter adjustments. So after adjustments, we predicted the results for three classes and compared them. So these are the our adjustments for our machine learning models. So in random forest, we used these kind of estimators, creations, and etc. Extra tree classifiers. We have number of forest trees and 100. We have just modified it, okay, because in by default parameters are different. So we have tried different adjustment for producing a better result, okay. So what are the performance? We have compared our result with our imbalanced data set and balanced data. So you can see it is a very significant changes in imbalance and balanced results. So imbalance, we have very minimum accuracy like 75, 72. So these four models. So in the case of oversampling and with the help of balancing oversampling way, so we have an extra tree classifier which have highest accuracy, precision, recall, FN and AUC area under curve. So results. So these are the some results for ROC of the four models without class imbalance and with the help of oversampling, we have the class balancing results. You can clearly see that four models have produces good AUC curves. So it's in the case of imbalancing, so we have not a good AUC curve, ROC curves. So so lower ROCs at here. Okay, so these are the some accuracy results because I initially told you that we have applied 12 machine learning models at here. So we have logistic model, regression, k-nearest neighbor, sport vector machines, decision tree classifiers. So you can see again extra tree classifier 98.2%, much better accuracy as compared to imbalancing data. So after adjustment of some hyperparameter. Okay, so this previous work is for the structured data. Now I'm considering we have published work on the structured, unstructured data for the images. So as you know, unstructured data are the free text in the form of images, audio, videos, all that kind of data are unstructured. Mostly 80% of the data are unstructured. So main are among the unstructuring data. So for this. We have published a paper which have had now going highly cited papers, efficient detection of of knee and anterior cruciate ligament from magnetic resonance imaging using deep learning approach. Okay, so at this we have applied customized. We made a customized residual network. So ResNet, very famous CNN based architecture, which is main classification models and there are many flavors, ResNet 101, ResNet 54, ResNet 18. So we have used a ResNet 18 because initial goal is to we have less number of parameters, and for this we have customized residual network. Okay, for this we have for unstructured data we applied and customized 14 layers architecture convolution with 6 different directions. Class balancing, okay, so we have done again class balancing and data augmentation at here. Our proposed ResNet 14 achieved average area under curve AUCs of 0.98%, 0.97, 0.996. So these are the values of the three classes. So healthy, partial, and ruptured. So respectively. So we can see the model total had 917 pickle images. We have pickle files. So pickle file we have generated slices and because the MIR have the main problem of variabilities in MIR slices, time consuming and error prone scanning and low resolution for MIR images. So this is our problem background as well. So propose hybrid class balancing technique on 3 ACLs and designated customized residual network with real-time data augmentation on 6 approaches, which I can then do later on. Achieved efficient detection results through sensitivity, specificity, precision, recall, F1, MIR, receiving, approaching ROCs, and AUC on 3 classes. So this is about our literature. So literature, we have different studies. 2019, we have the problem regarding CNN. They have applied the model of CNN in cascaded form. So no verification of bias result. Use only partial thickness. Only here's very less data sets to be here. As you can see, only 175 number of MRI images. So another study, Chang produces bounding box. So which is also a very low imbalanced sample. So so in this 260 MR images, and another bin which is actually the author of the data of Stanford University data set, which is a very famous data set, MRNet. So, and Andrew Ng is also the author of this study. So they have used the MR data sets and they've used for external validation. They have used our data set 917. Okay, so they have the problem of validation that could not be surgical confirmation. Data is not similar in case of validation sets. Another, this is the author of our data sets. Actually, they have open data sets available on the internet. You can see it. So they have used three classes. Okay, so but at their they only produce two tiers. They did not considering another tier of partial tier. So this is the main limitation of this study. Okay, the problem background again, I explained you earlier. We have the partial tier, full rupture tiers, and MR images are some problems on variabilities of images. So for this, in this study, we have applied customized ResNet 14 models. So for this, we have the data input. Initially, we have the data input. After pre-processing, like we are making a region of interest, and we making the slices of 75 by 75 cross one. We have channel one, and then we used our customized 14 layers ResNet model on it, and with real-time data augmentations and hybrid balancing way. So we have a hybrid class balancing. So we can say hybrid class balancing at here. We just enhance the data set of the low data set, increase it. Okay, and which class are partial and full ruptures, we increase their data sets in the CSV file, and we decrease the data sets of the data values in the higher class, which was in healthy tiers. So we just reduced in the CSV file. Okay, so that is called hybrid way. So over customized way, we propose these. This is our architecture of customized ways. So the total number of parameters 179,075, 70 million almost. So convolution layer, we are 13 convolutional. What have the changes we have in the depth? N cross 6 plus 2 is equal to 14. So 3 block of residual net at here, some kind of filter adjustment. So there is some problem of vanishing gradient, but after using our model, the problem of vanishing gradient is also reduced. Okay, so there is no problem of vanishing gradient. So performance of our model is, you can see, we have, I just told you, we have 6 different approaches. First one is without class balancing and data augmentation with k is equal to 5 cross validations, and second one is without class balancing and augmentations. So their results, test accuracy results, I just taken the test accuracy result, class balancing and without data augmentation, and 88.4% class balancing and data augmentation, this one, and at the last, class balancing and data augmentation with k is equal to 5 cross validation. So we have a very good result with the we have tried different approaches, like one by one we have with balance and without balance, with augmentation, real augmentation, without that augmentation. So we have producing a good results in the form of balancing. Okay. So these are the results of our class balancing with data augmentation with five-fold cross validations. So 0, 1, 2. So these are our classes. AUCs specificity or overall specificity we have found 94.7%. So you can see the some losses value, number of split loss values clearly shown. Our results have much lower loss as compared to other approaches, other six approaches. So comparison with the state-of-art methods, we can see this is the author's results. So you can see 0.894 and 0.9843. So the other author of the Stanford University authors, which have the results on the external data set 0.916. So we have just compared with the area under curve. Okay. So another study, 2022, their results of the with the help of ResNet, they have 0.81, 0.95. So these are abnormal and ACL tears. Yeah, it means full rupture tears and healthy tears. And with the help of MRNet, so this is the result of our results. So we can see we have clearly shown our results are much higher AUCs curves. So of the three classes, 0.917 for healthy, partial 0.95, and for ruptured is 0.99, which is almost 1.0. So what kind of results we have generated? So we can see we have checked over data sets like enter number of images. We have just entered the number of 251 full ruptured image predicted and actually full ruptured image. Okay, so this is the result. Some wrong where classification, full ruptured image predicted and healthy tear image group. So full ruptured and producing the result of partial. So these are the some false positives. So health group image predicted and this one. So and then I just wind up the conclusion of our study. The research contributed toward the improvement of the accuracy of the exciting detection of anterior cruciate ligament tear by proposing the method of ensemble learning, resonant 14 detection that accurately classify the healthy, partial, and full rupture tears in the magnetic resonance imaging. So that's all about my presentation. If you have any question, you can send me an email or just put me in a question regarding this. Okay. Thanks to again for the organizers of the SPML conferences. Okay. So thank you again. Take care.